Hello, my name is Evan Harrison. This is my final project, the 4-bit microprocessor. Right here, this is the kind of the full layout of the project. We've got our counter up here. I've also got the programmable read-only memory right here, the instruction decoder. Down here we've got, to the right, we've got the display that will display the letters and numbers. I've also got my register file right here, my multiplexer right here, and my ALU here. To dive in a little bit to the register file, it's got a few different sub-circuits. This is what I've called my 2x4 register. It is composed of a 2-word register, which is another sub-circuit I used, and that circuit is right here. It's basically selecting between using an address selector and determining what register to fill with data, whether it's register 0 or register 1. This register is also composed of another subcircuit called register, and this is my basic register, complete with D flip-flops and a write and a clock. And back to the main circuit, I'll also talk a little bit about the ALU. I've got my complete ALU right here, complete with the full adder circuit, the OR, and exclusive OR. We've got our multiplexer with our select lines here, in the right, and the clock. And I'm going to demonstrate how the project is working. I'm going to go ahead and enable the ticks. It's going to tick pretty quickly, but we can see that it's printing the words and the numbers. And so first we had hello, Brother Nelson. 3 plus 4 equals 7. 3 times 3 equals 9. Then for the first subtract, we did a software kind of based subtract, and what I had to do in the programmable read-only memory was I had to program the 3 to its 2's complementary additive inverse. Basically converted the 3 to its additive inverse so that I could add 4 plus negative 3 in the ALU ultimately. And as we can see, right here, I've got the display of the ALU. The additive inverse of 3 is added to the quantity of 4, giving us a value of 1, which is displayed now. And then the next step was to add this the subtract hardware. And to do that, I'll go back into my ALU really quickly. I created a subtract circuit, and I'll jump into that really quick. And what that is basically a circuit takes in 4 bits, and it has a selector to either just spit out and a multiplexer, I guess. Basically it will spit out just the bits that are going in if the selector is selected to 0. If it's selected to 1, however, it will go through this circuit, which will convert the number into its 2's complement additive inverse. And basically I'm using a part of an adder right here. I'm adding a 1 to the least significant bit, and then I'm adding 0 to the rest of the bits, so that we're just adding 1. And then I'm also using an inverter to flip the bits, to invert them all, and then adding 1 to that last bit. And that way we're converting to the 3-bit, the 2's complementary form. And that will allow the ALU to compute 4 plus negative 3 in this case, which will be 1. And I'll step through that really quickly. We've got 4 minus 3 equals, and then we can see right here our ALU has converted the negative 3, added the 4 and the negative 3 to get a value of 1. And we'll keep going, and the 1 is displayed. And that's my project.